This is question 63 on chemistry from the 2011 IMAT. So we're told that 8 grams of copper oxide is produced to 5.6 grams of copper using hydrogen gas. And we're given the relative atomic masses of copper and oxygen. So this is our equation. And so what is the percentage yield of copper compared to the theoretical maximum? So firstly, how do we calculate percentage yield? So if it's compared to the theoretical maximum, then the equation will be the mass that we obtain of copper divided by the theoretical maximum mass, and don't forget the times 100 to make it a percentage. So we have the mass of copper that we obtain, that's this 5.6 grams, and so what's its theoretical maximum mass? Well, if we know the mass of copper oxide that we put into the equation, then we should be able to work out theoretically how much copper this should produce. And what value do we need for this? We need the number of moles of copper oxide this is. So how do we work out moles from what we have? We know the equation is number of moles is mass divided by relative molecular mass. And if we're dealing with copper oxide, what is its relative molecular mass? So we have the atomic masses. We have 1 copper and 1 oxygen. So putting the numbers in, you have 64 plus 16, which is 80. So that's how many grams of copper oxide there are in 1 mole. So we have our mass, and we have our relative molecular mass. So how many moles is that? Let's put the numbers into this equation. We get 8 grams over 80 grams per mole, which is 0.1 moles of copper oxide. So if we have this many moles of copper oxide, then theoretically, how many moles of copper will this produce? Well, it's a 1-to-1 reacting ratio, so this will also be how many moles we should produce of copper. So what now? Well, we don't need the theoretical moles, we need the theoretical mass. So how do we get this from the moles? Well, we can rearrange the equation that we started with to get mass, but of course this needs to be number of moles times relative atomic mass this time, because we're just dealing with copper. So let's put the numbers in. We have 0.1 moles times 64 grams in 1 mole of copper. And so what's 0.1 times 64? This is 6.4 grams, theoretically, of copper. So we have the numbers that we need. We have the mass that we obtain, that's this 5.6, and our theoretical maximum mass, which is 6.4. So let's plug the numbers in. We get, for our percentage yield, 5.6 divided by 6.4. Don't forget the times 100. So what would this be? Well, what's 56 over 64? So this is 7/8. Then what's 7/8 of 100? Well, we know 1/8 is 12.5, so 7/8 will be 87.5%. So this is our final answer of our potential yield of copper. So this corresponds on the question paper to answer E.